So here are a few matrix problems. First problem is we've got an inequality and we want to solve for A. So that's kind of the same idea as solving for a variable in an equation, but now the variable is a matrix. Okay, so we're going to apply properties of the transpose and of the inverse in order to solve for A. So the idea is that I'd like to have only A, let's say, on the left hand side. So first thing I want to do is I want to get rid of maybe matrix B here and the C inverse. Okay, so let's start with the B. So to get rid of B, I need to multiply by its inverse, but I need to multiply on the right hand side. It's very important. I cannot just put the B inverse in between here. I can't do that. Okay, I can, because matrix multiplication does not necessarily commute. So I cannot just squeeze in a B inverse into here. So I need to multiply by B inverse either from the right or the left, but since I want to cancel my B's, I want to multiply from the right. So I'm going to do the same thing here. B squared, B inverse. So this is I. So essentially anything times I is the initial matrix I'm multiplying it by, which is in this case C inverse A transpose. And on this side I get C inverse. Now B to the power 2, B to the power minus 1. I can add the powers just like I add powers with numbers. Okay, so if you're not convinced with that you can do this with matrices, remember that B squared, that's like B times B. And if I multiply by B to the minus 1, these cancel out because it's matrix I, so it gives me B. So you can see that it's the same as adding the exponents together. So yes, I can do that. I can put a B there. Next thing is I want to get rid of C. Now to get rid of C, I need to multiply by C from the left. So if I do this, I get A transpose here, and here I get C inverse B. But as we can see, this is also I, so I get that A transpose is B. And finally, if I just want to have A, I need to use the property that if I transpose a transpose, I get back A. So if I transpose both sides, I'm going to get A on the left-hand side and B transpose on the right-hand side, and that's my solution. So the next problem is this one. You can try it on your own, maybe first. I didn't mention this in the first problem, but maybe you want to do that and see how it goes. You're going to assume that all matrices here are invertible, so I'm going to assume that B is invertible. Okay, so in these problems they usually tell you that. Let's assume A and B are invertible matrices. So to get rid of A, what do I need to do? So what I tend to show students maybe first is, let's say you have something similar but with real numbers. So let's say you're trying to solve this equation, for instance. Okay, then everything's a real number. A is a variable, that's a real number. What would you do? Well, you would get rid of the power minus 1 first, essentially by raising everything to the power minus 1 on both sides. And if you raise something that's to the power minus 1 to the power minus 1, you get 1. So that's why it sort of goes away. But on the other side, 9 gets raised to the power minus 1. After that, you would subtract 3. And finally, you would divide by 7. So it's the exact same process you're going to perform with your matrix equation. So first we're going to get rid of the inverse by taking the inverse of the inverse. So here we're applying the fact that A inverse is A itself. So I'm taking the inverse of this matrix. I take the inverse of the inverse, I get back the original matrix. But of course on this side I get B inverse because I'm raising everything. It's as if I'm raising everything to the minus 1 on both sides. Okay, so after that I want to get rid of, so right now I'm at this step. Now I want to get rid of 3i. So what do I do? I subtract 3i. So I'm going to get something like this. I'm going to get 7a is b inverse minus 3i. After that, I want to get rid of the times 7, which is a scalar, so I just multiply by 1 over 7. Here we go, and that's a. So for our next problem, again, we want to solve for a. Try to do it on your own, and then check the solution. So first thing, I want to maybe get rid of this b, so I'm going to multiply by b inverse on both sides. So if I do this, I get a inverse equals cb inverse, and b times b inverse is I, so anything times I will give you the initial matrix, so I just get cb inverse on this side. And now I want to get rid of the inverse, or the power minus 1 that's applied to a. So I take the inverse of the inverse, and I get a here, and on this side I just get cb, and that's it. Okay, and the last question, we want to simplify this expression as much as possible. Okay, so let's go. Well, once again, maybe you want to try it on your own first and compare. First thing that comes to mind, you see I've got b inverse b, that's just I. I've got some matrix AC, multiply, and that's inverted, and multiplied by AC, so that's, again, just I here. If you didn't see that and you distribute the minus 1, you'd get c minus 1, a minus 1 here, right? Careful, because the order of the letters change, and times AC, you see a minus 1a is I, and c minus 1c is going to give you I. So, well, let's be careful here. You're going to get c minus 1 I c, and I times c is c. So that's why you get I again. But the easiest thing is really to see that you've got a matrix, AC, for which we take the inverse and multiply by the same matrix, AC. So you get I. So A times I is going to give you A. So maybe let's do this part slowly. Okay. Now I've got the transpose of a product. So remember, the property we're going to use here is AB transpose is B transpose A transpose. So again, the order in which the product is done once you distribute the transpose changes. Okay. And you've got A transpose transpose, that's just A. If you transpose the transpose, you get back the original matrix. Now this is just D. Well, it stays the way it is, but usually we're going to write it conveniently like this, d to the minus t times A. And I believe there's nothing more that I can do here to simplify the expression. So one thing I can't do, okay, this is false. If you cannot regroup the a's together. You cannot write that this is a squared d to the minus t or d to the minus t a squared. You cannot group the a's together because they're not one next to each other. You could do that if you could commute d to the minus t with a. Okay, you could do that if I could do this, then it would work. I could write it as d to the minus t a squared, but no one's telling me that these two matrices commute, so I cannot do that. So all of these are false, okay, in general. So that's my final answer here after I've simplified.